All right, picking up where we left off yesterday. We were practicing with our segment addition postulate, what in the notes at first got called the betweenness of points, segment addition postulate. So we want to find the measure or the length of this segment right here. That segment, DF, is being made up of two smaller segments put together. What are the two smaller segments that are being put together to make that big one? What are the two smaller segments that are being put together to make this big segment? DE is one of them. And then what's the other one? Close. EF. DE is one, EF is the other. When I take DE and I put it together with EF, it gives me the distance from D all the way to F. Speaking of DE, how big is segment DE? 2 7/10 inches. So in the place of DE, I'm going to put 2 7/10. We didn't have to work with fractions yesterday. What do you have to have if you're going to add fractions together? Common denominator. Well, how big is segment EF? 5 9/10. Do our two fractions have the same denominators? Yes, so we could add our fractions together. Yep, we would get 16/10, 1 6/10, and then we'd also add the whole numbers. You're absolutely correct. The other thing that we could do is change it into its decimal form also. Does anybody happen to know what 7 divided by 10 is in its decimal form? 0.7. So 2 7/10 would become 2.7. What do you think 5 9/10 would be? 5.9. And then to find the length of segment DF, I need to add those two together. Let's add the decimal one, and then we'll go look at the fraction one to make sure that we get the same answer either way. 8.6. Should we have units with that? Inches. 8.6 inches is equal to segment DF. All right, let's look at the fraction form. Usually I don't care whether you guys work with the fractions or whether you change it into decimal form. If it ever makes a big difference, I'll make sure that we talk about it in class so that you know exactly how you need to handle those fractions. But if I don't say you have to leave it in fraction form, I'm okay if you want to change it into decimals. These are mixed numbers. They have whole numbers and fractions. For mixed numbers, you add the whole number parts together. 2 plus 5 would give me 7. Well, that's bigger than 7. 7/10 and 9/10. We heard earlier that that's 16 over 10. 16 over 10 is a top-heavy fraction, right, where the top's bigger than the bottom. So I can split that, take the 10 out. That would give me another 1. That makes my 7 go up to an 8. And then that would leave me with 6 over 10. That's that 0.6 right there. Nice work. All right, let's look at number 4. Number 4, I want to find the measurement of segment QR. I see 3 line segments, 3 distinct line segments when I look at this picture right here. I want to know what the names of the smaller 2 are. What are the 2 smaller segments that are being put together? Those are our measurements. Just what are the names of the segments, though? Give me P to Q. So PQ is one of my segments. Close. PR is my biggest segment. QR. PQ plus QR gives me segment PR. All right, now let's get into the numbers. How big is segment PQ? 6 5/8. Let's change that into its decimal form. Can somebody grab a calculator? It's okay if you grab your cell phone calculator for right now. I want to know what 5 divided by 8 on the calculator is. 0.625. Well, we had that 6 whole number out in front, so this would be 6.625. How big is segment QR? Look carefully. I want QR. We don't know. From Q over to R, just this piece right here, we don't know how big that is. So I have to leave that as QR. Do we know how big the whole big segment is, PR? That one we do know. How big's that? 13 3/4. Does anybody know what 3/4 is in its decimal form? 0.75, so 13.75. I want to get the QR all by itself. So what operation could I use to make this 6.625 cancel out? Subtraction. Let's minus 6.625 from both sides. Grab those calculators again. I am okay if you are using your cell phone calculator right now. 13.75 minus 6.625. 7.125. Should we have units with that? What should those units be? Feet. All right. I want you guys to take about a minute to do part D on your own. Take about a minute to do part D on your own. No, that's okay. So when I have a line segment like this, the segment addition postulate says that I can take the measurement of this smaller piece and add that to the measurement of this smaller piece, and that gives me the length from here to here. So, for example, I took my ruler out. I measured both of these. This guy's 7 inches. This guy's 5 inches. If I take those and put them together, and I measure from here to here, 12. 7 plus 5. That's exactly what we're doing. So on those, we're going the other way. I'm saying if this is 12, and I know this is 5, what do I have if I take that away? That's what we're doing on this part down here. So this segment right here, PQ, plus this segment right here, QR, is equal to this, PR. So I would start by writing that down first. Small plus small equals the big. That's what you're going to do. Yes, it is.
But you have to do all that fancy.
I would highly recommend yes, because it will get more complicated later, and that'll help you keep track of what you're doing. So you do the two little ones, PQ, and then plus QR equals PR. All right, your answer should look like this, and then you fill in the pieces. Yep. So then in the place of PQ, we don't know what that is, so we just leave that as a PQ because I don't have a number to sub in there. In the place of QR, we make a substitution because we know how big that piece is. And in the place of PR, we make another substitution. Basically algebra. Yep, we write our equation first, then we make any substitutions that we have, and then we solve it from there. All right, let's flip it over. Write and solve equations to find measurements. Find the value of x and BC. So this is what we're looking for. Find the value of x and BC. If B is between A and C. Now there's something that they didn't give us on this problem that they've given us on the last 4. What did we have to work with on the last 4 problems that we don't have this time? We don't have a picture. You're right, they give us expressions instead of just straight numbers, but they didn't give us a picture. So we're going to draw a picture. Anytime they don't give you a picture to work with, we absolutely need to be drawing a picture. That will help you make sure you're getting the problem set up correctly. Usually, if there's a mistake in a problem, it came from not setting it up right. Drawing that picture helps you solve that mistake or fix that mistake. It says B is between, so B is somewhere on this line like this. I don't know where in the middle, but it's somewhere in the middle. And then what are the names of the 2 endpoints? A and C. It tells me right here that from A all the way over to C is 4x minus 12. Segment AB, so this little piece from right here over to here, that is x units big. And from B over to C, so from here over to here, is 2x plus 3. So the first thing that we need to do now, if we're going to find x and the value of BC, we need to set up an equation that uses my segment addition postulate. What are the 2 smaller segments in the picture? AB is one of them, and BC is the other one. When I put AB and BC together, this one together with this one, that gives me what big segment? AC. So set up the equation first. Now we're going to make some substitutions. What can I put in the place of AB? How big is that? X. What about BC? How big was that one? 2x plus 3. What should go in the place of AC? 4x minus 12. I want to pause right here before we do any algebra now to solve this. Do you guys understand where I got the x, the 2x plus 3, and the 4x minus 12 from? Okay. This statement up at the top, AB plus BC equals AC, you need to have that written down because that's how you know where to put those different pieces at. The 2 that are being added together are always the small 2, and they should have a letter in common, the one that's in the middle. The 2 smaller ones add to make the bigger one. All right, let's solve this Algebra 1 style. On the left-hand side, I've got some like terms that I need to combine before I can do anything else. I'm going to combine the x and the 2x together to get what? 3x. So I have 3x plus 3, I bring that 3 down, equals 4x minus 12. Now I need to get my x's to the same side. I have x's on the left and I have x's on the right. I want x's in one side only. So I can either minus 4x from both sides, or I can minus 3x from both sides. I'm going to minus the 3x from both sides. Oops. Sit for me, guys. I need to make one of them cancel out. It doesn't matter whether I make the 3x or the 4x cancel out, but one of them has to cancel. Over here on the left, we're going to bring that 3 straight down. What is 4x minus 3x? 1x, so just x. And then bring down my minus 12. What's the last thing I need to do to get the x all by itself? Move the 12. This is a minus 12 right here. How am I going to make it cancel out? Plus 12. So we're going to plus 12 to both sides because negative 12 plus 12 is 0, and 0 is a cancel. 3 plus 12 gives me 15, so x is 15. What did they want me to find again? What were the directions at the beginning? Find the value of x. We did that. Anything else? And BC. Well, what did they tell me about segment BC at the beginning? It's equal to 2x plus 3. And we just figured out using algebra that x is how big? So 2 times 15 plus 3. What is 2 times 15? 30 plus 3? 33. Now we've done both pieces of this. Nice work. Right. Last new concept for this section. Something called congruence. If I have objects that are the same shape and size, we say that they are congruent. I've had snacks on the brain all morning today, so my best example that I've been able to come up with is when I open the new box of Cheetos that I have to go with my lunch, or sorry, not Cheetos, Cheez-Its, little crackers. When I take a handful out, as long as they're not broken, every single Cheez-It will look like every other Cheez-It in there. They are congruent to each other, same size, same shape, same color, same. That is what congruent means. We use these little tick marks here to show congruence. Notice they have one tick mark here and one tick mark here, and then they're showing that they are both 1.7 centimeters. They're the same exact size. Sometimes we're going to have a lot of things going on in the picture, and we might have already marked 2 things as congruent and put 1 tick mark on each one. In that case, we would put 2 tick marks on other things that are congruent. So it doesn't matter how many tick marks there are on these line segments, as long as the ones that are the same size have a matching number of tick marks. So if this has 2 tick marks and this one has 2 tick marks, I'm saying they are the same size. Over here we have 1 tick mark and 1 tick mark, so those are the same size. And then this symbol right here, an equal sign with a squiggle over the top, that's our symbol for congruent. Objects can be congruent, like Cheez-Its or line segments. The measurements or the lengths of congruent things can be equal. Same measure. The lengths are equal. So objects can be congruent. Lengths are equal. Let's see if we can use this in practice. Let's look down at number 6. Find the value of x if Q is between P and R. Well, they're talking about a line segment and points, but they didn't give me a picture to look at. So the first thing I need to do is I need to draw a picture. So I'm going to draw a line segment. Q is somewhere in the middle on this line segment because it said Q is between. P and R are my endpoints. PQ is 6x plus 20. So from here over is 6x plus 20. QR from here to here is 2 times x plus 6. And then they give me this. What does that mean again? What does that squiggle over the equal sign mean? Congruent. And what does congruent mean again? Same shape, same size. And what do I use to show that they're the same size? The little tick marks. Now, with the way my picture is drawn, does it look like those two segments are the same size? No, that's why those marks are so important. My art is bad. I drew the picture wrong. Those should be the same size segments. Instead of fixing my picture, I'm going to put those marks on there, and that means they are the same size, even though I did a bad art. All right, we need to find x here now. We were told that segment PQ is the same size and shape, is congruent to segment QR. If the shapes are the same, then that means their lengths are, I'm looking for an E word, equal. The length of segment PQ is just PQ with nothing over the top. Remember, if there's nothing on top, it means length. So the length of PQ is equal to the length of QR. How big did we say PQ was again? 6x plus 20. Bring down my equal sign here. How big is QR? 2 times x plus 6. And now we have an algebra problem that we're going to solve. First thing I notice about this algebra problem is that we've got parentheses here. What can I do with this 2 out in front to get rid of those parentheses? Multiply, distribute. We're going to use the distributive property, which is multiplication. So my left side just comes down, 6x plus 20. On the right side, I multiply. 2 times x is 2x. What's 2 times 6? 12. When I look at just one side of the equal sign or the other, I don't have any like terms to combine. There's only 6x here, and 20 is not a like term. There's a 2x here, 12 is not a like term. So now I need to group my x's on the same side. How do I get my x's on just one side? Minus 2x from both sides. 6x minus 2x gives me 4x. Bring down my plus 20. Bring down my positive 12. I want to get the x all alone, so what do I do next? Minus 20. 20 is the one that has to go. I don't minus 12 from both sides because that would give me a 0 over there and too much on the side where x is. I want x to be alone. So now I have 4x equals, what's 12 minus 20? Negative 8. Last but not least, we're going to divide both sides by 4. What is negative 8 divided by 4? Negative 2. Nice work. All right, let's try one more like that. Need your hand up for me, dear. We're going to work on this example now. What's the first thing I need to do on the second part? Yep. What's the first thing I need to do? I'm going to draw a picture. Yes, they didn't give us a picture. We need to draw a picture. It says U is between T and V. So here's my line segment. Here's U. And then my endpoints are called T and V. How big is it from T over to U? 6x plus 35. They tell me that right here. What about from U over to V? 4 times x plus 7. That's right here. And what else do I know? TU and UV are congruent. I did one tick mark on each of these to show that they were the same size. Could this be a right way to do this? Would that show me that they're congruent on the second part? What's wrong with it? Has to be the same number. If I put 2 tick marks on this one and the other one's the same size, it needs 2 marks. If it doesn't have the same number of marks, it's not the same size. Segment TU is congruent to segment UV if the objects, if the segments are congruent, same size, same shape, what does that mean about their measurements? They are equal. The measurement of TU is equal to the measurement of UV. How big is segment TU? 6x plus 35. Is that right? Okay, I wasn't looking at it. I was just writing stuff down. How big is UV? 4 times x plus 7. First thing I want to do, we did our substitution. That's how I got here. So yes, we did want to do substitution. What do I do after I do the substitution? We're going to do distributive property. 4 gets distributed to both of these pieces. Bring down the left, 6x plus 35. What do I get when I distribute over here? 4x plus 28. What now? Get the x's to one side. We're going to minus 4x from both sides. Could I minus 6x from both sides instead? Yep, that would be okay. 2x plus 35 equals 28. Now what do I do? Subtract 35 from both sides. We want to get the x alone, so it has to be the 35 that goes away. 2x equals, what's 28 minus 35? Negative 7. Divide both sides by 2. Am I going to get a whole number answer here? No. What is the decimal form of -7 divided by 2? What is -7 divided by 2 in decimal form? -3.5. You can leave that in its fraction form. I don't care whether you write it decimal form or fraction form. Either one would be fine. All right. New homework that you guys grabbed on your way in the door is due on Thursday. If you are a junior, you will need to watch the video tomorrow because you're going to have your class meeting during this time. Juniors, you'll need to watch the video to catch up. We're going to do a couple more examples, but we're not going to be talking about anything that's brand new. There's no new concepts coming. Just more practice examples. Homework's due on Thursday. The other thing that happens on Thursday is your very first skills check of the semester. So of the stuff that we've covered so far in these two sections, I'm going to look at the test and pick out questions from these sections that are going to be covered on the test. And then I'll give you questions like that so that you have a good idea of how you're doing right now in preparing for the test. And you know what you might need to study more to make sure that you are ready on time. We will be doing page 8 tomorrow. That will not take us all of our class time. The remaining class time after we're done with page 8, you guys will have in-class homework time. Sorry, juniors.